Welcome to SS2 Physics, Term 3, Week 9. Astrophysics applies the laws of physics to understand stars, galaxies, and the universe. It is one of the most awe-inspiring branches of science. It tells us where we came from, the Big Bang and stellar nucleosynthesis, what our Sun is, a middle-aged main sequence star, and what our ultimate fate may be. By the end of this lesson, you will describe the life cycle of a star, define key astronomical distances, explain the Big Bang theory and evidence for it, and answer WAEC questions on astrophysics and cosmology. Let us begin. The universe is immensely large. Ordinary units of measurement, meters, kilometers, are impractical. Astronomical distance units, astronomical unit, AU. The average distance from the Earth to the Sun equals 1.496 times 10 superscript 1 superscript 1 m is almost equal to 150 million kilometers, used for distances within the solar system. Light year, LY. The distance light travels in 1 year equals c times, seconds in a year, equals 3 times 10 times 3.156 times 10 equals 9.46 times 10 superscript 1 m is almost equal to 9.46 times 10 superscript 1 superscript 2 kilometer, used for interstellar and intergalactic distances. Parsec, PC1 PC equals 3.086 times 10 superscript 1 m equals 3.26 light years. Defined as the distance at which 1 AU subtends an angle of 1 arcsecond, used in professional astronomy. Key distances: Earth to Sun equals 1 AU equals 8.3 light minutes. Earth to nearest star, Proxima Centauri, equals 4.24 light years equals 1.30 pc. Diameter of the Milky Way galaxy equals 100,000 light-years is almost equal to 30,000 pc. Distance to Andromeda Galaxy, a nearest large galaxy, equals 2.5 million light-years. Observable universe equals about 93 billion light-years in diameter. Electromagnetic spectrum in astronomy. Astronomers use the entire EM spectrum, not just visible light. Radio waves, cold hydrogen gas, pulsars, cosmic microwave background, CMB. Infrared, cool stars, dust clouds, galaxy centers. Visible light, stars at surface temperatures 3000 to 30,000 K, ultraviolet, hot stars, white dwarfs. X-rays, neutron stars, black hole accretion disks, supernova remnants. Gamma rays, supernovae, gamma ray burst, radioactive decay from stellar nucleosynthesis. Stars are born, evolve, and die. The timescales are millions to billions of years. Life cycle of a star like the Sun: medium mass nebula, stellar nursery, a cloud of gas, mainly hydrogen, and dust. Gravity causes it to contract. Temperature rises as gravitational potential energy converts to thermal energy. Protostar, central region heats up to millions of degrees, not yet a true star. Nuclear fusion has not begun. Main sequence star, core temperature reaches is almost equal to 10 million K. Hydrogen fusion begins, 4 times 1-1 H4-2 E, a net reaction, through several steps. This releases enormous energy, E equals mc squared, as gamma radiation. Radiation pressure balances gravity, hydrostatic equilibrium. The Sun has been a main sequence star for 4.6 billion years and will remain so for another 5 billion. Red giant: when hydrogen in core is exhausted, core contracts, outer layers expand and cool to red color. Helium fusion begins in the core, BECE. For Sun-like stars, red giant planetary nebula, or outer layers expelled, white dwarf, small, hot, dense remnant, no fusion, cooling over billions of years. Life cycle of a massive star: more than 8 solar masses. Massive stars burn fuel faster. Main sequence lifetimes of only millions of years, not billions. After red supergiant phase, the core iron cannot be fused further. Iron has maximum binding energy per nucleon, collapses suddenly in a fraction of a second. Supernova explosion, one of the most energetic events in the universe. The explosion is visible across the galaxy. Heavy elements, beyond iron, are synthesized in the supernova and spread into space. Remnant after supernova: if core mass is 1.4 to 3 solar masses. Neutron star, matter compressed to neutron density, rapidly rotating pulsar, emits radio beams. If core mass is greater than 3 solar masses black hole, gravity so strong that escape velocity exceeds c, light cannot escape. The Big Bang Theory. The universe began approximately 13.8 billion years ago from an extremely hot, dense state, not an explosion into space but an expansion of space itself. All matter, energy, space, and time began at this singularity. Evidence for the Big Bang. 1. Hubble's law and expansion of the universe. 1929 Edwin Hubble observed that distant galaxies are moving away from us, and the further they are, the faster they recede. The relationship, V equals h0 times d, where V equals recession velocity, d equals distance to galaxy, h0 equals Hubble constant is almost equal to 70 km per second per mpc. The recession is detected via redshift. Light from receding galaxies has longer, redder, wavelengths than expected, Doppler effect for light. If all galaxies are moving apart today, running the film backwards means they were all in the same place at some finite time in the past, the Big Bang. 2. Cosmic microwave background radiation, CMB discovered in 1965 by Penzias and Wilson. Thermal radiation fills the entire observable universe with a temperature of 2.7 K. This is the cold afterglow of the hot early universe, redshifted from visible light to microwave frequencies over 13.8 billion years. 3. Abundance of light elements, Big Bang nucleosynthesis. In the first few minutes after the Big Bang, predicts the universe should be about 75% hydrogen and 25% helium, by mass, consistent with observations. Dark matter and dark energy, ordinary matter, what we can see, constitutes only about 5% of the universe. Dark matter, about 27%, detected by its gravitational effects on galaxies and galaxy clusters but not yet directly observed. Dark energy, about 68%, unknown form of energy that is causing the expansion of the universe to accelerate, discovered in 1998 from observations of distant Type I supernovae. WAEC questions on astrophysics typically include naming and defining units of astronomical distance, AU, light year, parsec, describing the life cycle of the Sun or a massive star, explaining how nuclear fusion powers stars, stating evidence for the Big Bang Theory or Hubble's law, CMB, element abundances, defining redshift and explaining its connection to the expansion of the universe, explaining what a black hole is and how it forms. Work definitions. Redshift, the increase in wavelength, shift towards red end of spectrum, of light from a receding source, due to the Doppler effect. Galaxies show redshift, they are moving away, universe is expanding. Hubble's law, V equals h0d, the recession speed of a galaxy is proportional to its distance. Implies all parts of the universe were once much closer together. CMB, 2.7 K microwave radiation filling the universe uniformly, the cold remnant of the hot early universe. Neutron star, extremely dense stellar remnant, neutron degenerate matter, if rotating rapidly, emits regular radio pulses pulsar. Black hole, region of spacetime where gravity is so strong that nothing, not even light, can escape, formed when a massive stellar core, more than 3 solar masses, collapses after a supernova. Event horizon, the boundary of a black hole from within which nothing can escape. Key points, astronomical distances, AU, Earth-Sun, light-year, distance light travels in 1 year equals 9.46 times 10 superscript 1 m, parsec, 3.26 ly. Star life cycle, Sun-like nebula protesta main sequence, H fusion, billions of years, red giant planetary nebula white dwarf. Massive star, nebula protesta main sequence red supergiant supernova neutron star or black hole. Stars produce energy by nuclear fusion, E equals mc squared, heavier elements are built up through stellar evolution on supernovae. Big Bang Theory, 13.8 billion years ago supported by Hubble's law, redshift, V equals h0d, CMB, 2.7 K background radiation, element abundances, 75% H, 25% He. Universe composition, 5% ordinary matter, 27% dark matter, 68% dark energy. Black holes, from collapse of massive stellar cores, event horizon, light cannot escape. WAEC test, distance units, life cycle diagrams, fusion in stars, Big Bang evidence, definitions of redshift, CMB, Hubble's law.